Hey, welcome back to the Config Bench. I'm John, and today we're going to do a full bench review of the ANENG SZ308 digital multimeter. Every function live on the bench, honest verdict at the end. Let's get into it. Before we get into the bench, let's do a quick unpack. I picked this up off of AliExpress for under $5. And I know what you're thinking, but if you're in a budget and looking for an entry-level equipment, this is an option worth knowing about. It arrived in a simple box. Inside you're going to see a meter, 2 probes, basic instruction sheet, nothing fancy, but everything you need to get started. Note, no battery is included, so a 9-volt battery is going to be needed. As you can see, the box arrived. It's all in decent condition. When we open that box up, inside we got some test leads. We got instruction sheet that's in a few different languages. I'll be honest, I haven't really looked at that. We've got the test leads, and they're a budget pair of test leads comparable to the price that we paid for this meter. It was under a $5 meter. Crazy price. I did it as an experiment, just see that if someone was on a budget, would buying a meter this cheap be worth their effort and time. And I think at the end you'll see what I think. The meter itself, there it is. At the top here, you're going to see that it has a digital display. I've already installed my 9-volt battery, so don't expect that to just come on. So we got the digital LCD display. It's clear, easy to read. Selecting volts over here. Selecting DC volts over here. Selecting AC volts over here. Selecting amps and milliamps over here. We spoke on the short video about a square wave output, and that's with that selection there. And then ohms is down here. Quite a range. We got the connectors, the common for voltage, ohms, milliamps, diodes, and sound test, is here. And then for DC amps is over here. So for continuity, we're going to test a 1000 ohm resistor to get started. First, we make a selection on our meter. I'm going to choose 2000 range, and my 1000 ohm resistor, I am testing that. And if we see on the meter back there, it's showing 965 ohms. And if we say, really? 1000 ohm resistor, 965 ohms, and then we try another one, and this one is 986. So why do we have a discrepancy? I've got 2 resistors that are 900 and that are supposedly 1000 ohms resistor, and we just saw 2 different values being displayed. We're getting back to what I've been referring to as tolerances. The resistors I purchase are rather cheap. I do that so I can buy them cheaply. They probably have a 5% tolerance range. So if you saw the 967 and the 986 or whatever the ranges were, they are within tolerance. So there's 965, 5% tolerance is about 50 ohms, so that's within tolerance. And then if we measure this guy, that is 986, and again 50 ohms of tolerance, that's within specs. And now we're going to check a diode, and this diode, if you're familiar with diodes, continuity should be in one direction, and there it is, 464 ohms in one direction. And if we reverse it, we're going to find that it's infinity, and we would expect that for that. So there is our ohms demonstration. So in our DC current example, we have a 9-volt source, and we have a series circuit of two 47 ohm resistors. And if we do the math, and this is important at this point to do the math, because 9 divided by 47 plus 47 equals 94 ohms. So here's, if we look in the background here, I don't know whether you can see it or not. In the background here, 9-volt battery, 9-volt source going through an amp meter, and 47 ohm plus 47 ohm. It comes out to 95.74 milliamps. And we just need to be very cautious that we get these settings correct on our amp meter so that we do not damage the amp meter. So what I've done is I've set it to 200 milliamps, anticipating that will be less than 200 milliamps. So I'm going to turn the power source on, which is a power supply. And right now we're coming out to 98 milliamps that you can see on the screen. So 95.7 versus 98. Again, if we go look at our tolerances for our components and the meter itself, I think we're well within the tolerance. Again, don't get hung up because there's slight differences in what the math is and what we end up seeing. Again, if you take in the tolerances up to 4 or 5% tolerances for the components, I think that will compensate for the differences we're seeing. And we're going to do a transistor test. And this particular transistor, you need to know the make and model of your transistor and to make sure that you put the legs, the emitter, base, and collector into the right holes. And there we are. And I have had no luck using this transistor tester. Well, let me put it in the proper position. In the proper position, I've done a few tests a couple different times, and I have just had no luck getting this transistor tester to work. You might have a better experience than I have, but so far I've used a couple different transistors and I've had absolutely no luck getting that test to work. I'll be honest, so the next test we're going to do is a square wave output. And I was very surprised to see this as an option. To do this test, we need our oscilloscope. And here we're using this little pocket oscilloscope. And we are going to connect the ground probe to the ground probe. Positive probe. And on the meter, there's a selection way down here for a digital display of a square wave. And if we pull up our little oscilloscope, there's a square wave. So I'm very impressed with that. It's showing a Vmax of 1.65 volts. We are doing DC measurement. Voltage peak to peak is 2.67. So is this as accurate and precise as you might have with a proper generator? It's not, but it sure does give you an option for your initial config bench and testing. So I thought that was kind of a neat display. So in summary, my verdict of this little meter: the fundamentals solid, voltage, resistance, continuity, current, all perform exactly as expected on the bench. The square wave reference output was a genuine surprise at this price point, and having the HFE socket built right into the face of the meter is a thoughtful touch. Now, a few things worth knowing before you buy. The transistor HFE tester up here, I wasn't able to get that to work. Now, someone else might find that I was doing it wrong, and God bless you, but I could not get that working. I tried it off video multiple times, and it just would not work for me. So I'm assuming that I'm doing something wrong. The meter is lightweight plastic construction. It's not intended to be ruggedized like maybe a fluke meter. So if you're going to take this out in a toolbox and throw it around, bash it around, you might find out this isn't going to be as rugged as you'd hope it to be. One other thing I noticed in this, there is no fold out in the back here, you know, for a stand like our little oscilloscope here. There is no fold out, so when you're trying to get measurements done, you're going to have to find something to kind of lean it up against so that you can do your measuring and monitoring. What else? Bottom line, for the beginner bench, a starter kit or a backup meter, the SC308, punches it all. It's a nice little meter for its price point. Just go into purchasing this with realistic expectations. Anyway, I'm John with the Config Bench, and see you next time.